Hi, here's the same normal random variable maple worksheet, except this time I'm going to use z-scores and use a z-table instead of integrating. So same exact problems, but just another method for solving them. Um, okay, so we're talking about lengths of steel sheets. So x will equal the length of sheet. And we already know that the lengths are normally distributed with means of 75 and standard deviations of 1. And I'm trying to find the probability that the length, or that if I pick a randomly selected sheet, that its length is between 74.5 and 75.8. And I did it in the previous worksheet using integration, and now I'm going to use a z-score. So what I want to do is a transformation. And to transform to a z-score, what we do is we take our random variable, we subtract off its mean, and divide by its standard deviation. So here's what I'm doing. This is just text. So the probability that x is between 74.5 and 75.8 is the same thing as the probability, and I convert to z-scores, 74.5 minus the mean divided by the standard deviation. This becomes a standard normal random variable, and we always use z to represent that. And on top it's 75.8 minus the mean divided by the standard deviation. Okay, so I think that looks good. So here's what I'm trying to do then. What is 74.5 minus 75 divided by 1 is negative 0.05, and let me 75.8 minus 75 divided by 1 is 0.08. So I want to find the probability of z being between negative 0.5 and 0.8. So let me make another line here. I'm going to go to my z table. I pulled it up in PDF Annotator so I can write a little nice on it. So first I want to find the probability z is less than 0.08. So I go over here. Well, let me see what that 0.8. Sorry, 0.8. So there you go, 0.8, and I think I can just say I want to use a pen, and yeah, let's go right here. Here is, no, obviously I have the wrong thing. Oh, here maybe is pen, I don't know, in black. I think that's what I have. So I just, I want, well, it should be right there. Oh, why is that not working? Because I want to write text. No, I think I just want to highlight. Okay, there's a dog. Right here is 0.80 is 7881. So that's the probability of being to the left of 0.8, 7881. So 0.7881. And maybe, well, I can't draw a picture on here. And now I want to subtract off the probability being less than negative 0.50. Here is negative 0.50 is right here is 3085. So 0.3085, which is 4796, and this is what we got when we did it by integration. I mean, the table isn't as exact, but is fairly close, and I'm happy with that. I mean, if you use a table, I'm not gonna be mad if you're not as accurate as integrating, because this is just another method. Okay, so we finished that one. Let's see it again, because that's probably pretty fast. Suppose the scores on a dexterity test. Okay, so we let x equal scores on test. They have a normal distribution with a mu of 12 and a sigma of 3. I want to find the probability that someone takes the test and their score is less than 14. So that's the same thing as a z-score being less than 14 minus 12 divided by 3. Let me see, so that's the probability that z is less than 2/3, which is approximately the probability that z is less than 0.67. So let's just go to the table and look for z being less than 0.67. So 6/7's over here. Not quite. Let's pull this up a little bit. So here's 6 and here's 7. So if I go down, here it is 7486. 0.7486. 0.7486. I think in the last time we did it, and the other one when we integrated, we got 0.7475, but that's, you know, partly because of the table and we're not quite as accurate, and you know, because we're not taking out to 0.6666, we rounded at 0.67, so we're not going to be exact. Yeah, now I just did something with a binomial, but that's the same as on the other worksheet. Mostly now I'm just trying to show you how to use the table. Okay, let's do one with the table where we have to go the opposite direction. So x is equal to IQ scores, which are normally distributed with a mu of 110 and a sigma of 20. And I want to find the 95th percentile. So if you imagine the normal curve, I'm way up in the right tail. In general, let's say this way, what is the 95th percentile of a normal 0, 1? If I can just figure out how many standard deviations away from the center that the 95th percentile is, I can easily then convert it to the normal with a mu of 110 and sigma 20. So first I just want to find this. What z value leaves 95% area in the tail? So I go here, let's go down a little bit. Well, we can see I'm looking for 95%, and that's really close. No, it's really in between these, right? So 1.645. So here's how I'm going to say it. The probability that z is less than 1.645 is equal to 95%. So in other words, if I go 1.64 standard deviations to the right of my normal curve, I'm going to have 95% area to the left. So that's easy now. I could just take 110 plus 1.645 times the standard deviation. So 142.9 is the score, such that 95% of scores are less than it. Okay, so I'm going to do this one more time, but with Minitab the next time. Okay, I must be getting faster. Okay, see you soon.